All right, so in today's video, we're going to be talking about Pythagoras. Now, what is Pythagoras? A hint, it is not a species of snake. It is not a type of snake. Pythagoras is the name of a Greek mathematician from a long time ago in a galaxy far, far away. Now, Pythagoras had this idea that if we had a right-angled triangle, which is basically just a triangle with a right angle, which is just a 90-degree angle. If we have a triangle like that, and we call this side A and this side B, then in every single triangle, this side H would be the longest, right? And we would get this formula. H squared plus is equal to A squared plus B squared. Now, H here stands for hypotenuse, which is an important piece of terminology to know because the hypotenuse will always be the longest side of a triangle. And the hypotenuse will also be the side opposite to the 90-degree angle, as you can see illustrated in this example here. Okay, so this is the important thing to remember. The hypotenuse is the side opposite to the 90-degree angle. It's the longest side of a right-angled triangle. And to find the hypotenuse, we use this fancy formula. H squared is equal to A squared plus B squared, where A and B are the other sides of the right-angled triangle, and H is just the hypotenuse. Right, let's go through some examples. All right, so pause the video and try this example on your own, and then see what I get as well. So the first thing is we want to remember that we have this formula, and then we want to, it's great to have a formula, but you have to actually know what it means and how we can use it. So let's say that 3 will be our A and 4 will be our B. So then we can use H squared is equal to 3 squared plus 4 squared. So then H squared is equal to 9 plus 16. So H squared is 25. Okay, are we done? No, we're not done. We have to get rid of this square root. Wow, giving the answer. We have to get rid of the square, and the way we get rid of a square is by taking the square root. So we take the square root on both sides, we get that H is equal to 5. Okay, and so we have our answer here, H is equal to 5. Right, so let's try this question here now. So what can we do to find C in this case? We want to find C, and how can we do it? So the first thing to note is that C is going to be the hypotenuse because it's the angle that is opposite to the right angle triangle, the right angle in the triangle. So we can use that H squared is equal to A squared plus B squared. And in this case, C will be H. Okay, so we can rewrite this just as C squared is equal to, we can put 3 in the place of A and 6 in the place of B. 3 squared plus 6 squared, so C squared is equal to 9 plus 36, which is 45. So then we have that C squared is equal to 45. We take the square root, and C is equal to the square root of 45. Okay, now if you wanted to take this further, you could write this in third form, but this is not important right now. You could write it as, basically that would just be the square root of 9 times the square root of 5, which is 3 root 5. But that's not too important to remember right now. The important thing is just how we got the answer for C, which is up here. Okay, so C is the square root of 45. Now, the thing that made this maybe a bit more challenging is that the triangle wasn't in the same position as it was in the last few ones. But that shouldn't be too much of an issue because we aren't really concerned about the position of the triangle as long as we can find that right angle we can find the hypotenuse, then we're sorted. So just remember, it doesn't matter what position the triangle's in, as long as we can find the right angle, we're sorted, because we can find the hypotenuse. Right, so here's the next question. Pause the video, as always, try to do it on your own, and then we will go through the answer. So the first step here is to find the hypotenuse. So the hypotenuse is equal to 5. So perhaps red is not the best color to use for this. The hypotenuse is equal to 5. Okay, so now in this case, we're not trying to find the hypotenuse because it's given to us. So we have to think a bit on our toes for this one. So again, let's just write down what we know. We know that h is going to be 5. We'll call this one a. So a is going to be 3. And we'll let this one be b. So b is going to be x. Now, we still have our formula, h squared is equal to a squared plus b squared. And if we substitute our values in here, we get that 5 squared is equal to 3 squared plus x squared. So we get that 25 is equal to 9 plus x squared. So we can try to get x to be the subject by subtracting 9 on both sides. And from this, we get that we take the square root of both sides, and we get that x is equal to 4. So in the cases of right-angled triangles, you won't always be asked to solve for the hypotenuse. You might be asked to solve for a or for b, or you might be able to ask to prove that it's a right-angled triangle. Now, as long as you remember that, according to Pythagoras' theorem, a squared plus b squared is equal to h squared, where h is the hypotenuse, you can manipulate that formula to find any of the sides of a right-angled triangle. And if you get given a triangle and you get asked, is this triangle a right-angled triangle? You can take two of the sides and you take two of the shorter sides and see if the square of those sides add up to the square of the hypotenuse. I'll give an example of that, but that's just how you would prove if a triangle is in fact a right-angled triangle. All right, so this is the type of question that I was talking about. You would have to show, is this a right-angled triangle or not? And I would like for you to think about how we would show if it's a right-angled triangle or not. So notice here that if this were a right-angled triangle, this would be the hypotenuse. Now, the reason for that is because that is the largest side. The side is 12, the side is 5, and the side is 13. So 13 is clearly the largest of those three. So because of that, that would be the hypotenuse. So we would use the same formula, h squared is equal to a squared plus b squared. And if we can show that 13 squared is equal to 12 squared plus 5 squared, then we will have shown that this is a right-angled triangle. Because remember that this formula is only true for right-angled triangles. Okay, so if we can prove this, then we're done. It's really that simple. So 13 squared is 169, 12 squared is 144, 5 squared is 25, and then we can see that that adds up to 169, so this is in fact a right-angled triangle. Okay, so just to summarize, the longest side is equal to h if a squared plus b squared equals h squared, right-angled triangle. I'll just say right triangle for shortness. So it's really not that bad. The essential things to remember from this video is just, where is the hypotenuse? The hypotenuse is A, it's the longest side of the triangle, and B, it'll be opposite to the right angle, so it'll be there. That would be the right angle in this triangle. And then the second thing is h squared is equal to a squared plus b squared. You're going to be probably sick of hearing that formula by the end of learning Pythagoras. But it's a really helpful formula that you'll use if you continue your studies. It's used constantly in engineering, in mathematical modeling. It's used quite a bit in a couple of things. Physics definitely uses it. So it's quite a useful formula to remember. So it's really helpful. So yeah, just remember the formula: h squared is equal to a squared plus b squared. Longest side will be the hypotenuse. The hypotenuse is also the side that is opposite to the 90-degree angle. And to prove that a triangle is right angled, we just find the longest side and we prove that that squared is equal to a squared plus b squared, where a and b are just the other two sides. And lastly, if you're given the hypotenuse and another side, so for example, if this, in this case, we were given 13 and 12, we would be able to find, that's the wrong color, we would be able to find x here by just manipulating the Pythagoras formula. Okay, so if you have any questions, feel free to ask.